take a quiz.
No. Because there's no do-overs. This isn't golf. There's no mulligans. All right, 6-3. We're going to do parametric equations. Parametric equations. All right, so here we go. We have part A and B, and then we'll do the rest of it tomorrow. So first thing, let's talk about parametric curves. Parametric curves. Do you remember parametrics at all? Yeah, maybe? We studied this way back in like, I don't know, chapter 1 or something. So here you go. Recall that this is what a parametric function is. You have a function of x, which we'll call f of t. And then you have y equals some other function of t. And t is called the parameter. T is the parameter. And what you do is you can generate points by plugging in t, values for t. So you plug in a value for t into this function, it'll give you an x value. You plug that same t into this one, it'll give you the y value, and that's your point. Okay? And usually it's specified on an interval we call I, on an interval I. So they'll say t is from this to this. All right, so here we go. We're going to do these on our calculator. So if they ask you to graph and you do it on your calculator, make sure that you draw a graph of it on your paper. So let's graph this one. X equals t squared plus 2. And let's go minus 2, sorry. T squared minus 2. And then y equals 3t. Probably wouldn't have made it that much of a difference, it's what I have on my paper. All right, we're going to graph this on 3 separate intervals just to see what happens, the changes that it makes. So letter A, we're going to graph this from -3 to +1. Okay? -3 to +1. And we're going to draw a graph of this. All right, so do you remember how to get to parametric graphing? Yeah. So you go to mode, and let's go to radian mode, by the way. Change your calculator back to radians, because we're actually going to do trigonometry with parametric graphing. And then right now we're in function mode, so we're going to be in parametric. And then later on we're going to learn polar, which is the one next to it. Okay, so your mode should look like this. You have radian and you have parametric. All right, so go to y equals. And you might have some stuff in there, so we'll clear that out. And we're going to do t squared minus 2 and 3t. All right, go ahead and hit zoom 6. That's not going to be our window, but I want everyone to have a standard window right now. So zoom 6 is your standard basic window. And if you go to window right here, that's where you want to change your t-min and your t-max. So most of the time for parametrics, it'll be from 0 to 2 pi. 6.28, about 2 pi, 0 to 2 pi. We want this to go from -3 to +1. Is that all the way down? The thing's like heating up again, yeah? Okay, and now hit graph. Don't hit zoom 6 again, that'll give you back 0 to 2 pi. So -3 to 1, and graph, and it actually gives you a better graph because that's the right t's that I want. Okay, so if I had to sketch a graph of this, you can do this a couple of ways. One, you can go over to the table, and that'll give you, when t is 1, all that stuff. So t is -3 is going to be my first point, which is 7, -9. So 1, 2, 3, 4, 5, 6, 7, -9. So there's my first point. And then you might want to graph a couple other ones, like 0, -2, or for t equals 0, you would graph -2, 0, which is right here. And then you can also, if you don't like that, you can hit trace and follow this along the way, which a lot of people like better than the table. If you go back to your graph and hit trace, it'll give you when t equals -3. You can plug in when t equals -2, when t equals positive 1, stuff like that. So t equals 1 at negative 1, 3. Negative 1, 3. And so this is what the graph would look like. It looks like part of a sideways parabola. And don't draw arrows on the ends because this is a restricted interval from t equals, you don't have to write this, but t equals negative 3 to t equals positive 1. And that's it. Just that section of the graph. Yeah?
So when you're like, you're solving an equation, you're graphing like a function, right? So it's like every time your answer, like that's what it would be.
Well, that's not a function.
Okay, I'm just confused with like
Yeah.
what like.
These,
like
so
graphing.
graphing parametrics allows us to graph non-functions.
Okay.
Yeah. So like a lot of times, you know, when you're in function mode, you can only graph functions, right? So you can graph parabolas that go up and down. You can graph, you know, other things. You can't graph circles in function mode unless you graph two equations of the bottom and the top. So this allows us to graph things that are not functions, just relations. I'm gonna show you how to get rid of the t and get it back into just x and y, which is what you're used to. All right. Let's go ahead and do one more. I said 3, but I think we could just do one more. Let's now change this from negative 3 to positive 3. Okay? Same function, or not function, same relation, same parametric graph, but just we're going to change the t from negative 3 to 3.
Like, why do we have to have like that range? Like, why does that?
It's given to us.
Okay.
Yeah.
Is there like a reason behind it now?
Well, yeah, I mean, if you were going to do this and it said from t equals 0 seconds to 5 seconds only, you restrict the range of t. So, yeah. So this is just, we're going to change it, see what it looks like. Negative 3 to positive 3 graph. You might feel a little bit better about that because it's symmetric. Do you like symmetry? Yeah, I know, right? This one feels like, did I do it wrong? Something's wrong here. But for the next one, you still get that same point. So trace, t equals negative 3 gives us that point 7, negative 9. So 1, 2, 3, 4, 5, 6, 7. I don't know if I have graph paper over there. And then at t equals 0, that was our vertex, which was at negative 2, 0. And then t equals positive 3 is at 7, positive 9. I'll call that 9. And so your graph looks like this. And that's it. And make sure that you stop. Okay? Some people used to be that you had to draw arrows to show what direction you're going, but you don't have to anymore. So this is from t equals negative 3 to t equals positive 3. This value right there is t equals 0. You could generate a table by going to the table, stuff like that.
And then you have to write like t equals negative 3, t
No,
equals 3.
you don't have to. I'm just showing you what it looks like on there. Okay, pretty good? You guys remember doing this a little bit? Yeah? All right, so now why do they have us doing this again? We've already done this. Well, because you've learned some new things along the way. So now what we're going to do is we're going to graph, I'm going to do it, x equals cosine of t, and y equals sine of t. And let's go ahead and we're going to graph this.
Is number 3?
2.
Oh, we have AB. Okay.
Yeah. We're going to graph this on the interval from 0 to 2 pi. Okay, they might write it like that. They also might write it like this, 0 to 2 pi, just so you know. Okay? That's why you want to be in radian mode, because these are in radians. If you were in degree mode, graphing from 0 to 2 pi, it wouldn't look right. So let's do it. You ready? Here we go. Let's graph it. So y equals, don't do it, I did it, cosine t and sine t. And then window is now going to be 0 to 2 pi. And then I hit graph. Oh, super tiny. You can zoom in on that if you want to. It looks like an ellipse because of my rectangular window. If I hit zoom square, that'll look a little bit better. It's actually a circle. You know what circle that is?
Unit circle.
Yes, it is. That's the unit circle.
So cool.
It is cool. Not so much? Yeah, look at that. It goes to 1 in each direction, goes around, and it's the unit circle. Beautiful. You can go over to the table and check it out. Those are some ugly values over there, but you can if you want to. Okay, so that's pretty cool there. It's a unit circle. You want to do kind of a fun one? It says on my paper fun. I don't know what this actually looks like, so this is kind of fun for me too. Number 3. Oh, by the way, what is the equation of the unit circle? Like if you were going to do a Cartesian equation of it, you know, not a function, but with just x and y. Do you remember circles at all last year? X squared plus y squared equals r squared. So yeah, I'm going to teach you how to do that in just a minute, just to show you. That's the equation of a circle, centered at the origin. Okay, let's do this one. It says fun. We'll see how fun it is. X equals sine t minus t cosine t. Oh, this. No. And then y equals, no, and I never read it as sin, like sin of pi over 6. It's always sine and cosine. No, because some people will. They'll say sin of t. I'm like, no, it's sine t. Cosine t, and I don't read that as cost either, plus t sine t, and we're going to do this on the interval from 0 to 6 pi. Woo! This is going to be fun.
So does this fit in at all with what we just took a quiz on?
No.
Okay.
No, this chapter is additional topics or applications of trigonometry, or additional topics in trig is what the old book used to call it.
Okay.
So it's like a potpourri, hodgepodge, if you will, of topics.
Potluck.
Potluck, yes, yes. What do you like at the potluck? You like the KFC bucket?
No.
Yeah. You don't like anything? You like the potato salad that's been sitting out in the hot sun all day? Nasty. All right, 0 to 6 pi. Did you graph it? Is it fun?
It's like a square.
It looks like a square?
Yeah.
Oh, I'm super zoomed in. Dang it. I'm going to hit zoom 6 and then I'm going to change it. Oh, it's still thinking.
It's a spiral. Oh,
It is a spiral, isn't it?
what?
Oh, that's a spiral. So 0 to 6 pi. That is fun. Look at that. Whee! Oh, that's so cute.
Wait, mine looks like an
Okay, do this. You plugged it in. Sine t, close parentheses, minus t cosine t.
Yeah.
And then cosine t plus t sine t. Hit zoom 6 for a minute. Zoom 6 will give you a standard window. That's a little part of the spiral. And then now go back to window, because now that's just 0 to 2 pi. If I do 6 pi, it's going to make it go out more. So not 6.28, but 6 times pi. 6 pi is 18.8 something. And then hit graph. That is fun. I'm glad we did that one. Okay, so parametrics allow us to graph all kinds of interesting things like spirals and stuff. Okay, so it actually stops somewhere. I don't know where it stops, but I'm just going to draw an arrow. All right, now let's go to part B. Part B is going to show us how to eliminate the parameter. Sounds fancy. Eliminate the parameter. Okay, I already eliminated the parameter on one of these. See this one up here? The parameter is t. To get rid of t means to now write your equation in something that doesn't have t in it. Okay, I eliminated the parameter. I wrote this circle in this form with no t in it. The stuff we're used to, right? We're not used to t. That t just showed up and we're like, what? Okay, so what you're going to do is you're going to go from they call it going from a parametric equation to a rectangular, they call it a rectangular equation. Doesn't have anything to do with rectangles. You know, like the XY grid, it's rectangular equation in X and Y. Some people call it a Cartesian equation because it's on a Cartesian plane instead of a parametric plane. So I'll show you how to do these, okay? Eliminate the parameter. By the way, you will get parametrics again in calculus. It happens in like the first week of school or something. It's in the first chapter of the book. They just kind of run through it, how to do it, stuff like that. Just so you're aware. Okay, so what's this, number 4? Number 4. All right, suppose that we're given x equals 1 minus 2t and y equals 2 minus t. And t is from negative infinity to infinity. If you had to graph that, by the way, you can't plug in negative infinity to infinity in your calculator. You could just do negative 10 to 10. So if you're going to do this on your calculator, you would plug in negative 10 to 10.
Why sometimes you make it like greater than or equal to, and sometimes you just make it greater. Oh, it's infinity.
Infinity. Yep, you knew it. Okay, so now we're going to eliminate the parameter. Eliminate t. Okay, we're going to make this, that says eliminate t. We're going to make this into just our regular Cartesian equation. So this is what you want to do. You want to go to it and you want to solve for t for one of them. And it really doesn't matter which one you solve for. Usually it'd be like the easier one in a way.
For what?
So we could solve for y. That would be fine. So then t would equal 2 minus y. Okay? All I did was I added t to this side and I subtract y to the other side. And now I'm going to take that and I'm going to plug it in for t there. So that I get x equals 1 minus 2 times 2 minus y. And now I'm going to clean this up and I'm going to solve for y. Because most of the time, if it's a function, of course, let's solve for y equals yada, yada, yada. Okay, so go ahead and distribute. X equals 1 minus 4 plus 2y. So then x equals negative 3 plus 2y. And we're going to solve for y. What's that? Yeah, we could have. I thought about that too. It doesn't really matter either way. If you started by solving here x equal or t equals for x and plug it into y, that probably would have been a little bit better. But either way, it doesn't matter. So let's go ahead and solve. So we get 2y equals x plus 3, and then divide everybody by 2. And I'm going to write this like this. I'm not going to write x plus 3 all over 2. I'm going to write it the way that I'm used to these things, how they're written. So it's x over 2, which is 1/2 x, plus 3 over 2, which is 3/2. And what is that the graph of? No. A line. It's linear. It's to the first power. Yeah. So this is a line. So they might say eliminate the parameter and then analyze it. Analyze it is kind of questionable because, like, what do you mean analyze it? They just say it's a line and then describe what it is. So it has a slope of 1/2 and it has a y-intercept of 3/2. We haven't done lines in a long time, huh? Yeah.
So if we were graphing like a non-function
Uh-huh.
t, and right now we just got it into like function form, right?
Yes, we did. This one ended up being a function. I'm going to do one in just a minute where it's not.
Okay.
Yeah, and I'll show you what you do. Yeah, so that one right there, basic line, solve for t, plug it back in, you're good. Okay, so let's talk about that first one that we did today. We did x equals t squared minus 2.
Number 5.
Oh, thank you. Number 5. And y equals 3t. Okay. And you remember this was not a function, this was a sideways parabola. And let's go ahead and say that t is from negative infinity to infinity again. And if they don't tell you what the interval of t is, it's automatically just all of everything, okay? All real numbers for t. All right, so for this one, the last one, I didn't have to solve for y, but this one you should solve for t in the y equation here. Because t is squared up here, you don't want to solve for that. You should have plus and minus. Blech. So let's go ahead and solve for t. So we get that y over 3 is equal to t. And once again, we're going to pick that up and we're going to plug it in. And you're not going to get something that's all that nice. You get x equals y over 3 squared minus 2, which you can write as x equals 1/9 y squared minus 2. And I know it's been a long time, and I wish that they would have put chapter 10 in front of this lesson, because that's just a sideways parabola opening to the right, if you recognize that from last year's conic sections, but it's been like a year since then. For real, like over a year. No, under a year. All right, let's do one more. Number 6. Last one for today, and I'll get your quizzes back. Okay, let's do this one. Let's say you have x equals 2 cosine t and y equals 2 sine t. And I want to, and they tell me that t is from 0 to 2 pi here. That really doesn't matter much. Okay? 0 to 2 pi. And I want to eliminate the parameter. Okay, now you look at this and you're like, are you kidding me? We're going to have to do cosine inverse of both sides? No, you don't. Okay? Let me show you what you're going to do. You're going to take each of them and solve for cosine in the first one and solve for sine in the second one. Okay? So go ahead and do that. So we get that the cosine of t is equal to x over 2. And then you get that the sine of t is equal to y over 2. Now, here comes my favorite part. We're going to take each side of both of these equations, and we're going to square them. Square that one, and we'll square that one. Since it's an equation, we're just doing under one side as we do onto the other, and that's fine. And so what I end up with is, I'm going to go over here. I end up with cosine squared t equals x squared over 4. And sine squared t equals y squared over 4. Now, take a look at this. We're going to take these two equations and we're going to add them up. And so, on the left side, we get what? Which is 1. Cosine squared t plus sine squared t equals 1. Chills, right, Matthew? Major math goosebumps, yep. And then equals, and we add those up, x squared over 4 plus y squared over 4. And then let's go ahead and clear out all our fractions by multiplying both sides of the equation by 4. And we're going to rearrange some stuff. I get x squared plus y squared equals 4. It's a circle with radius 2. Amazing, right?
Yeah.
That was pretty good.
That was cool.
Okay,